Hello students, welcome to the physics class, and today we'll discuss about this second part of the second PUC physics 14th chapter semiconductor electronics. In a first part of this video, we are discuss about what is a semiconductor, classification of semiconductor based on band theory and different type of semiconductor. And in this particular video, we are discussing about semiconductor devices. First, we'll see what is the semiconductor devices. So, if you see any electronic devices, electronic circuits, we can find some of these type of devices like diodes, transistors, LEDs, light emitting diodes, or ICs, integrated circuit, etc. And these are called semiconductor devices. Let us see how these semiconductor devices works and what are the different type of semiconductor devices commonly used, etc. First, I'll discuss about PN diodes or PN junctions. See how this PN junction is formed. What is PN junctions? See, when a P type of material is electrically fused with a N type of materials, we got PN junctions formed. Now observe in pictures, one side is P type of material means holes are majority charge carrier, other side N type of semiconductor, the electrons are majority charge carrier. When they are electrically fused, it forms a junctions, and this is called PN junction or semiconductor diodes. And the circuit symbol is shown in figure, and it is a triangles with a straight line. This is a one anodes as a triangle side, and the straight line side is called cathodes. So that there will be two terminals semiconductor devices. And these semiconductor diodes, how it is formed, formation of PN junction, let us see. Say electrons and holes, that is electron form N regions and holes form P regions, will leave behind because of these majority charge carriers, and they are diffuse, and when they are migrate from N region to P regions or holes from P region to N regions, it leaves behind the donor and acceptor ions near these junctions. And these regions, the junctions which is depleted of these mobile charge carriers is called depletion regions, and that depletion region is thickness is about some 10 to power minus 6 meter, means micrometer. A thin layer region is formed, and because it loses some of the majority charge carriers, means from N region it loses electrons, from P region it loses holes, that a small potential difference is developed across the junction. This is called junction potentials. Okay? The potential difference across the depletion layer is called potential barrier, and that potential barrier for germanium is 0.3 volt and for silicon 0.7 volt, and this is called potential barrier or junction potential of a semiconductor. Next we'll see biasing of a semiconductor diodes. When you are going to apply a potential difference, external potential difference by connecting a battery, then it is called biasing of a semiconductor. There will be two type of biasing. One is forward bias, another is reverse bias. What is a forward bias means? Suppose you connect a P side of this semiconductor diode is connected to the positive terminal of battery, and N side of diode is connected to the negative terminal of battery, then diode is said to be forward bias. Okay, as shown in figure, P side is connected for positive and N side is connected to negative, and this is forward bias circuits. What happen in forward bias? In this biasing, forward current flows due to majority charge carriers. Whatever I connected N regions is connected to a negative potential, P region is connected to positive potential. Due to this external applied voltage, it pushes this majority charge carriers, that from N regions electrons are flowing to the P regions. Like that, due to this majority charge carriers, the width of this depletion layer, whatever barrier potential is there, no, it is decreases, hence it conduct the current. As shown in figure, the electrons from this N region goes to P regions, above the barrier potential. You can observe in a figure also, there will be diagram is there, and initially up to this new voltage, what is barrier potential, there will be a conductivity low. After that the conductivity increases because barrier potential is vanishes. As a result, there will be conductivity takes place. And in reverse bias, okay, reverse bias means in this biasing, P side is connected for negative terminal of battery and N side is connected to positive terminal of battery. In these junctions, there will be a barrier potential is increases. How it is increases? Because the allow P side is connected for negative, all majority charge carriers attracted by negative potential of battery, and N side is connected positive, all electrons majority charge carriers are attracted by positive of battery. As a result, the junction potential or depletion regions width is increases. Hence, in this bias, a reverse current is flows due to minority carrier. A small amount of current flows, but that is due to minority carrier. All majority charge carriers are attracted by external potential. As a result, width of the depletion layer is increases. It does not conduct, or I can say it has a high resistivity in a reverse bias. And this is the characteristics of this particular diodes. In reverse bias it offers high resistance, in forward bias it offers low resistance. You see in a figure, there will be a VI characteristics of semiconductor diodes. Okay? In semiconductor diodes, if you apply a forward bias voltage versus current, if you plot a graph, as well as for a reverse bias, if you plot a VI graph, how it is shown in figure, and this particular graph is represent what is the characteristic, what is the behavior of this particular semiconductor diodes. This is important. We see in the figures, in a forward bias voltage at starts, it is increases slowly up to a voltage called new voltage. After that, it started to increase rapidly, and that particular voltage at which it started to increase rapidly is called cut-in voltage or new voltage. And this cut-in voltage is 0.7 volt in case of silicon diodes, because this junction barrier potential is 0.7 volt. After 0.7 volt, it increases, the current increases rapidly as the voltage increases. In reverse bias, what is the VI characteristic graph is again in down. You can observe this as a voltage increases, current is increases very small microamps of current is observed because it is a current due to minority charge carriers. But as going on increases voltage above certain voltage, the current increases abruptly, and this phenomenon is called breakdown. At this particular stage, the barrier potential is vanished, and due to that reasons, conductivity takes place, and voltage at which it occurs is called breakdown voltage. Okay, that is shown in figure. This is a VI characteristic of a semiconductor diode. Usually, this graph is asking for exams. Next, when these characteristics, what is a characteristic of semiconductor diodes? Okay, is given here. A PN junction diode is allow these charges to flow one direction, but not in opposite direction. In other words, I can say PN junction in forward bias it offers low resistance, and in reverse bias it offers high resistance. That is a speciality, that is a characteristics of this particular semiconductor diodes. You can observe in pictures, suppose voltage is applied in one direction, it conducts or it offers low resistance, but current in opposite direction it does not conduct. That is a very important characteristic of the semiconductor diodes, and it is used in a various applications, this particular property or characteristic of semiconductor diodes. Let us see what is the application of these diodes. Okay? And this particular property of diodes is used to convert alternating current to direct current, and this process of converting alternating current AC to direct current DC is called rectifications. Okay? And the device, a device which convert alternating current or voltage into direct current or voltage is called rectifier. Okay? And this is very important, the rectifier, and there will be two type of rectifier, and this rectifier converting a bidirectional current, alternating current. You can observe in a pictures the current which is alternative changing directions, which is called alternating current, to direct current, the direct current which is always flowing from positive to negative in one single direction, unidirectional current. And this conversion can do using a semiconductor diode. This is one of the important application of semiconductor diodes. Let us see there is in rectifiers half wave rectifier. What is half wave rectifier? A half wave rectifier is converting a half cycle of applied AC signal to DC signal. Half of AC alternating current to DC. You can observe in a picture there will be one circuit is given with a transformer, diode and load resistance. A input is given, AC input, and AC which is has to be rectified, means we have to convert into DC, is applied to primary of the transformer, and diode in series with the load resistance is connected to secondary of a transformer. And as the AC is applied, the alternating current is applied, it has a both positive and negative half cycles. That as in positive half cycle, and during this positive half cycle there is A of diodes, okay, semiconductor diode is positive, others the B of this particular transformer is negative, and during this positive half cycle of AC input, diode is forward biased because P side is become positive potentials and it conducts. But in another half cycle, you can observe in negative half cycles, this A is in a transformer, secondary transform become negative and B is become positive. As a result, the diode, P side of diode is connected to negative potential, diode is reverse bias. That during this negative half cycle of AC, diode is reverse bias. In reverse bias, you know that it does not conduct, it offers high resistance. Due to that reason, it does not conduct. In forward bias, it conducts. In reverse bias, it does not conduct. This particular property is used to convert a alternate current to direct current, but only half of the cycle will get in positive. This is why it's called half wave rectifier. Next we'll see full wave rectifier. What is a full wave rectifier? Again it is used two diodes. You can observe in a pictures. There will be a two diode is connected for a secondary of transformer, and for primary of transformer we are giving a AC input which is going to be rectified, and secondary transformer we have a center top transformer, like that means it has a center terminals, and other two terminals we connected to diodes, and these two diodes are parallel and connected to the center of the transformer with the load resistance. Like that, from this load resistance we are taking a output, and during this positive half cycle of AC input, A is positive and B is negative of this particular secondary transformer. As a result, diode D1 is forward bias, diode D2 is reverse bias, and using this particular diode which is in forward bias is conducts, and diode which is reverse bias does not conduct, so that current flows only through the diode D1, and across a load resistance upper half of this particular input AC is getting as a output. During negative half cycle, of input AC, A is become negative, B is become positive. Now diode D1 is reverse bias and D2 is forward bias. D1 is reverse bias, it does not conduct, and D2 is forward bias, it conducts. As a result, current is flowing through D2 now, but across the load resistance it is same as direction as the previous in positive half cycle. Because of that reason, same in a positive half cycles how we are getting output, similarly we are getting output in the same directions, that both positive and negative half cycle we are getting output in a same directions. This is a way we can convert a bidirectional current to unidirectional current, but completely for both positive as well as negative half cycle. This is why it is called full wave rectifier. Both half wave rectifier and full wave rectifiers are important for examination point of view. Next we will see we have a other type of diodes, a light emitting diodes, LEDs, photodiodes and solar cell. First we will see LED, light emitting diodes. What is light emitting diodes? It is converting electrical energy to light energy easily using a semiconductor diodes. Okay. You can observe in the pictures there will be different colors of LED you can observe commonly, and this is nothing but light emitting diodes. Let us see how it is works, this light emitting diodes. And is a diode works in a forward bias. A forward bias PN junction is there inside this particular LED, and it is emit a light due to recombination of electrons and holes take place at the junctions. At the holes of the p regions and electron from n regions is recombines and convert into light energy at these particular junctions. And when a battery is connected a forward bias. If a semiconductor materials of PN junction is a transparent, that a transparent material is placed, then light is emitting comes out, and light emitting at the junctions and becomes a source of light. Okay, and that's why it is called light emitting diodes. And different colors of light we can observe in a LEDs. Because of that reason, the color of light is depend upon which type of materials is doped for while making a semiconductor diodes. Like that, suppose if you made this particular semiconductor diodes by gallium arsenide, then it will get a infrared radiations. Gallium phosphate will get a green or red light. Gallium arsenide phosphate if you do, then you will get a red or yellow light. Like that we can get a different type of light, okay, from this particular diodes. Is called light emitting diodes. It find a number of application in a various field. That application is important. It is used in a remote controls, drum systems, optical communication, traffic lights, etc. And it also has some advantages. If you compare this ordinary conventional in-candle low power lamps, it has many advantages. What are the advantages? One thing, it has low operational voltage, less power, and fast actions. Quickly it is goes on and off, and warm up time is not required. Long life, and it has a cheap in cost also. These are the advantages of light emitting diodes. Next, another type of diodes which is often using for voltage controller as a Zener diode. A Zener diode is a special purpose of PN junction diodes. It is developed by a Zener, that's why named as a Zener diode, and it works as a reverse bias. You can observe in pictures. You can observe this, the anode is in red in color and cathode is black in color, and is identified and is connected in a reverse bias in a circuit. You can observe this. The P side is connected for negative, N side is connected with a load resistance for a positive. Then output is taken across this Zener diodes and symbol is given as in figure. And this particular Zener diodes, how it works, okay? And when a potential is applied, okay, across these Zener diodes, you will get a sharp breakdown voltage, and this voltage is called Zener voltage. After that, it is started to conduct, and when Zener diodes is why it is happens at a breakdown voltage, it will be observed in graph where the voltage is almost constant as the current increases. These are one important properties, and it is also called voltage regulator because of that reason. See, a Zener diode is fabricated with a heavily doped both P and N side junctions, and is apply a reverse bias voltage. V reaches a breakdown voltage Vz of a Zener. Then during this breakdown voltage, a large change in current voltages remain constant. Even current is increases large extent, but voltage is not increases beyond this Zener voltage, and voltages remain constant. Even current to this Zener diode is varies wide range, and this property is used as a voltage regulator. This property of Zener diode used to regulating power supply. Okay, but the supply of voltage may increase varies, but current should not varies. Then devices is to be safe. Okay, and to protect the devices, as a voltage regulator we are using in many electrical appliances as well as electronic appliances, and that is used by this particular Zener diode. it is the uses of Zener diode. It is used as a voltage regulators. And next one is photodiodes. The photodiode is a heavily doped PN junctions diodes, but it is operated in a reverse bias. Okay, it has a transparent window. When a light is falling on this diode is conducts. Okay, you can observe this circuit symbol also. When light is falling on a diodes, it is works. Okay, like that it is conducts. How it is works? Let us see. It is a heavily doped PN junctions diodes with a transparent window operated under a reverse bias, is connected for a reverse bias. When a light photons with energy h mu greater than that energy gap, E greater than energy gap of semiconductor falls on these junctions, electrons Holes pairs are generated, and as a result a electron hole pairs are generated at junction. It is conducts, and due to this reverse bias of electron is moved to n regions and holes are moved to p region, is giving a current in a external circuits. And these are working of photodiodes, and these photodiodes is used in many areas. Application of photodiodes. Okay. See here, when a light is falling, it conducts or a current is flows, and that strength of current is directly proportional to intensity of light. Like that, we can measure intensity of light using this by measuring current, as shown in figure. Now, photodiodes can be used as a photo detector or detect optical signals. That is one important. It is used in a supermarkets or for counting machines, and it is used in a camera light meters to measure intensity of light or street light, and is used some optical communications, as well as it is used in a remote controls of a TV or VCR. These are some application of photodiodes. Now next is solar cells. Solar cell is a junction diode. It is used to convert solar energy to electrical energy. It is converting the light, solar light energy, whatever, is converting to electrical energy by using a semiconductor junctions. See here, in this particular solar cell, N region is a thin and transparent, and P region is a thick. Okay, the P end is coated with a metal, that is a back contact, what I also can observe in pictures, and a metal finger electrodes, this is a metallic grid, is deposited over a N region, N end, and is act as a front contact. Like that, when this light is falling on this particular junctions, there will be electrons whose pairs are created. Of EMF by a solar cell has a three basic process: generation, separation, and collections. See, generation of electron holes pair due to light. When a light is falling on, there will be a electrons holes pairs generated at the junctions when a energy is h mu of a photon is greater than energy gap at a junctions. Then there will be a separation of electrons as holes pairs are created due to electric field at the depletion region, and due to this depletion region there will be electric field is there, and due to this electric field there will be separation is taking place. The electron is shipped to n side and holes shipped to p side. That these electrons reaching this n side are collected by a front contact, and holes reaching to p side is connected by back contact. That a potential difference is developed, that p side is become positive, n side is become negative. This is a voltage or EMF, and this is called photovoltage. By that we can convert a solar energy or sunlight energy to electric energy by using a solar cell. Next, digital electronics. Okay, what is a digital electronics? There is another branch of electronics. It is used by a digital signals. Okay? And here we are discussing about some basics about digital electronics, and that digital circuits works based on digital signals. Means it has a only two values is represented 0 and 1s as a input and output voltage, which is permissible as only two states, either low or high or on and off or 0 and 1s we are calling. But if we see is analog signals, but so far we discussed, it is a continuous time varying voltage. Okay, it is continuous time varying voltage. All voltage values with respect to this current is getting in this particular analog signal. But you can observe in picture the waveforms which has only two discrete voltages, okay, is possible, and either low or high, and this is called digital signals. A circuit which works based on these digital signals are called digital circuits, and that particular branch is called digital electronics. So of course, so first we will discuss some of the basic building blocks of digital electronics, that is called logic gate. The logic gates are basic building blocks of any digital system, and in these electronic circuits having two or more inputs and only one output. It has either one or two or more inputs, but it has only one output, and such devices are called logic gates. It is again made up of semiconductor diodes or transistors, and these logic gates are the digital circuits which follow some logical relations between input and output voltage. It has certain logic relations, and that logical relation we can represent with a table, that is called truth table. A table which shows all possible input and output combinations is called truth tables. Let us see there are some of the basic gates which is given in your syllabus. There will be 5 common logic gates are used: NOT, AND, OR, NAND, or NOR gate. There are some 5 common logic gates we are using. NOT, OR, AND gates are called fundamental or basic gates. NAND and NOR gates are called universal gates. And let us see one by one. This first we will discuss NOT gate. NOT gate is a electronic circuit that produces an inverted version of input to as its output. Inverted version means in a digital circuit it has only two states, 0 and 1s. For a 0 input it is giving 1 output. For a 1 input it is giving 0 output. Like that, whatever input we are given, output it is an inverter, and this is called NOT gate. Another is OR gate. You can observe in a circuit symbol, and there is a circuit symbol of OR gate, and it has a 2 inputs and 1 output. OR gate has a electrical circuit that is giving output is high when one or more of its input is high. If input is high means 1. We are getting output is 1 if either one of the input is 1 or both inputs is 1. You can observe here, both inputs are 0, 0, output is 0. But one of the input is 0 and 1, output is 1, 1, 0, output is 1, 1, 1, output is 1. That you can observe in a truth tables. If A and B are inputs and Y is output, for both inputs are 0, 0, output is 0, input is 0 and 1, output is 1, 1 and 0, output is 1, 1 and 1, output is 1. Like that, this circuit is works based on this truth table. Next we will get AND gate. AND gate is a gate which is again 2 input and output. Is electronic circuit that is giving high in output only if all the inputs are high. All the inputs high means both inputs are 1, output is 1, otherwise output is 0. You can observe in picture 0, 1, 0, 1, 0, 0, 0, 0, 0, but 1, 1 will get a 1. Both inputs are high, output is high. That you can represent in a truth table also. 0, 0, 0, 0, 1, 0, 1, 0, 0, but 1, 1, 1. NOR gate is a combination of NOT and OR gate, and that is called NOR gate. The combination of NOT and OR gate is equal to NOR gate. It is followed by a OR gate is followed by NOT gate. The output of all NOR gates is like this, and output is low if one of the input is high. Like that, any one of the input is high, output is low. If both inputs are low, output is high. Like that, 0, 0 it is giving 1, 0, 1, 1, 0 and 1, 1, output is 0. It is just complement of this OR gate, that is called NOR gate. And we have a NAND gate. It is a combination of NOT and AND gate is equal to NAND gate. Like that, it is a gate, AND gate is followed by NOT gate, we will get a NAND gate. The output of all the NAND gates are like this. It is a high output is all high, it is a input is low and high, but both inputs are high, output is low. Okay, if both inputs are high, output is low. That's for a 0 0 it is 1, 0 1 1, 1 0 1, but 1 1, both inputs are high, output is low. Okay, that output is 0. Okay, like that this is a one gate called NAND gate. It is a combination gate, and both NOR gate and NAND gates are called universal gate. In a modern day circuit, there will be many logic gates are used, and all are combined in a one single chip, and that is called integrated circuit or IC. And in this integrated circuit, many logic gates are fabricated. And this particular technology of fabricating this particular logic gates is called monolithic integrated circuit. This is about semiconductor we discuss in this particular video. Thank you.